Here we are for our last video in section 6.3. This is page 408, check your understanding. It says, suppose you roll a pair of fair six-sided dice until you get doubles. Let t equal the number of rolls it takes. So the first question, show that t is a geometric random variable. Again, anytime you're reading these questions, start to think of what the distribution is. Since we're looking at the number of rolls, we know that's a discrete distribution, so we automatically can throw out normal. Then looking between binomial and geometric, pay attention to the fact that it just says until you get doubles, which means we can keep rolling forever if we're that unlucky. So that gets rid of that fixed condition and should start to lead us towards geometric. For geometric, we're getting rid of the f and we're just looking at its. So for binomial, it was does it fit or if it fits. And then geometric, it's simply its. Get rid of the fixed condition. So again, the I is going to stand for independent. Geometric, we're looking for the first success. The t is still two possible outcomes. And here we do have two possible outcomes, rolling doubles or not rolling doubles. And then again, the s is still going to be that the probability is the same. So it does match our conditions. So we're going to say that this is a geometric distribution. And we know that the probability here of rolling doubles is 1 in 6. So for number 2, it says to find t equal to 3 and interpret this result in context. For geometric, I highly suggest don't worry about calculations, don't worry about any kind of formulas or anything to memorize. Just think about what's happening. If t is going to equal 3, that means that we had to remember t is the number of rolls it takes. The number of rolls it takes to get a double. So if t is equal to 3, that means the first time we get doubles is on our third roll. So if the first time we got doubles is on our third roll, then that means we rolled twice and didn't get doubles. So I'm going to roll twice and not get doubles. That means I'm going to fail twice. So if the probability of success is 1 out of 6, then the probability of a failure would be 5 out of 6. So I have 5 out of 6, I failed twice. Because they're independent, we said that they're independent, we multiply those together. So we failed twice, and then we succeeded once. 5 6 to the second, and then 1 6. And then if we put that into the calculator, we get 0.1157. Then to interpret that in the context, there is a 0.1157, or about 12%, probability that you will get the first set of doubles on the third roll of the dice. Now, I'm making this video over Thanksgiving break, and during Thanksgiving break, I've played Monopoly a number of times with my boys, and I can tell you that it's difficult to get doubles on the third roll. As this next question goes to, in the game of Monopoly, a player can get out of jail free by rolling doubles within 3 turns. Find the probability that this happens. If you've played Monopoly and ended up in jail as often as I have, you know it's not very successful, so you end up having to pay that $50. So we're going to find this probability. So that means we're not looking at that it happens for the first time on the third turn. It just needs to happen within those first 3. So the probability that t is less than or equal to 3. So we have to consider what's happening here. If t is going to be less than or equal to 3, we can have it happen on the first roll. So probability t is equal to 3. Or sorry, 1. It happens on the first roll. Or it happens on the second roll, or it happens on the third roll. Any of those things can happen. So we're going to turn those into our calculations. Happening on the first roll means on our first roll we have a success, so that would be 1 out of 6. Happening on the second roll, that means we failed the first time and then succeeded the second time. Or it happens on the third roll, which we already know is 0.1157. So then adding those up, we get 0.4213. So you have about a 42% chance of rolling doubles within your first 3 rolls. I apparently was very unlucky when I played Monopoly this week. So geometric distributions, I really like this distribution. To me, it's the one that makes the most sense. It's the one that's easiest just to think your way through. No need to memorize, just go ahead and think about what's happening.